Alrighty, Lucia, let's do this thing. We're going to show you how context and memory improve agent behavior.
Let's use the Planner agent as our example. We'll improve its context by giving it the ability to manage its sessions, add memory, and access other data sources. Jack, take it away.
Let's jump right into leveling up our Planner agent. Here, we're in anti-gravity. Look how easy it is to set up session and memory management in our agent. It's less than 20 lines of code. Easy peasy.
Lemon squeezy. You can see we're adding an ADK class to integrate agent platform sessions. This gives us the ability to make our agents stateful over time and modify context as needed. We can do the same thing for memory, attaching the agent to Agent Platform's memory bank, an enterprise-ready and fully managed memory service.
So, the next time we plan a route, the Planner agent will remember details from previous plans it created. The memory service will automatically create memories based on how and what we use the Planner agent for. It can even analyze completed simulations and store learnings to long-term memory for future plans to use. Now, let's bring even more data to our agent. There are a ton of local rules with the city of Las Vegas and the state of Nevada. Lucia, how can we bring this additional unstructured data to our Planner agent?
I'm so glad you asked. I want to show how data scientists and engineers can use IDEs with their workflows. These files are stored in many different structures and file types. To make this useful, we need to chunk the documents and transform them into embeddings, which are numerical representations of the text. The Planner agent can query the text and embeddings using Retrieval Augmented Generation, or RAG. Here, I prompted the data engineering agent to create a data pipeline to manage our SQL artifacts and orchestrate the document processing from a prompt.
The data engineering agent writes data models and pipelines from the prompt. It integrates with your code to bring software engineering practices to data engineering.
That is right. And now I'm using Lightning Engine for Apache Spark, an optimized engine that runs Spark lightning fast. This process reads each document and chunks it semantically using Document AI. So now we have quickly processed the chunks and saved them into this table in AlloyDB. Let's see the chunks.
All right, I can see the embeddings, but I want to focus on something super, super cool. We didn't have to create the embeddings manually. AlloyDB's auto embeddings feature will generate them for you based on the model that you specify.
And we can also see them in action. I'm running a semantic search for restrictions for running arrays on the Las Vegas Strip, and I added a filter for the city of Las Vegas. This will search the embedding space for the top results. And Jack, did you know about this rule? You can't have a camel on public roads.
Oh. You don't happen to know what the return policy on a camel is, do you? At least now our agent will be aware of our camel restrictions. So now we just need to plug this knowledge into the Planner agent so it can incorporate the traffic rules into the designs of our marathon route.
I got ahead of this and extended a scale from the official Google Cloud repo to make the agent an expert at using AlloyDB and vector functions. I also added a tool to our Planner agent that's committed to our code base. The agent uses these to call AlloyDB through a Google Cloud Remote MCP server. So Jack, shall we switch back to you and test our changes?
Let's do it. Let me open the simulation. Here's a previously planned route. We've rerun it now that we are managing context better and have added memory. Let's see how it looks.
Now the Planner agent keeps track and has access to the latest context, like what landmarks and the current route passes by. And now local rules are being fetched as part of the planning process. Taking a look at the message history, we can see that the Planner agent recalled the previous detail pulling from its long-term memory of past simulations.
And Lucia, check out the difference here. The gray line is where we started, but the colorful one is our new path.
By managing context efficiently and adding memory to our agent, you can see our simulation adjusted its route based on the memory and data it now has.
Thanks, everybody.